Hey guys, welcome back to the channel. Today I'm so excited because we're going to be doing another micro project. Today we're going to be doing a simulation. We're actually doing a million simulations of a game of roulette, and then after that we're going to talk about a popular betting strategy and then talk about why it does not work. I am so excited, so let's grab our laptops and get started. Alright guys, let's get started on this micro project. So this one is going to be about the Martingale betting strategy. So for a little summary, the strategy basically entails that you start by betting $1 for a game of roulette, right? And then every single time that you lose your roulette game, you want to bet double the amount that you bet before. So if we start by betting $1, we will bet $2 if we lose, because in theory, if you win that $2 bet, you'd be making up for that $1 bet from before. Then similarly, if you continue to lose, let's say we lost our $2 bet, let's bet $4 next. And so that would make up for the $1, $2, and $4 bets from before. And so until you win, they want you to keep doubling your money. And so this in theory seems like it works, right? Because even if you're going on a really unlucky streak, at one point you're gonna win, right? And so at that point, then that one win is gonna make up for all of your losses from before. So it makes sense when you think about it, and honestly, when I was first introduced to this betting system, I was also confused because I felt like this was just an infinite money glitch. But we're going to talk about this a little bit, and then we're going to run some simulations and prove why this doesn't work. So I'm so excited. Let's get started. So the first thing that we're going to do is create a simple simulation, which is to basically just simulate the number in a roulette game. So what we're going to want to do is we're going to want to run a million games of roulette. And for now, all we really want is just to see what number that the roulette rolls on. So I'm going to start by going to the Discovery Module 1, and I'm going to look at the simulations. And so there's a very basic pattern that we follow for most simulations, and it looks like this. And so I'm going to sort of copy this from my simulation, but obviously modify the variables so that they match what I want. But we're going to pull this up. So for our simulation, what we want is we need a couple of Python variables first. So let's start with money. So let's say that our money starts at $100,000. So we're going to set money is equal to $100,000. And then our current bet is going to be $1. So these are just going to be variables that we have in the beginning. So we're not going to use these right now, but these will come in later. So we just want to set them right now. All right. And the part that does matter for us, though, is we're going to want to copy what they have right here. So we're going to want to do data equals this to create a list. And then we're going to start with the for loop. So for I in range. So this is going to tell us how many times this for loop is going to iterate before stopping, right? So here they have 600 because it looks like they're rolling a dice 600 times. For us, we're going to want to simulate a million games of roulette. So we're going to do for I in range 1 million. And then we're going to do a colon to signify that we're starting a for loop. And then we're going to have number is going to be equal to, and then we're going to do random.rounded. So this is going to basically simulate us picking a random number. But now we need to figure out what our range is, right? So we know that for roulette, it's going to be either 0, 0, 0, 1, 2, 3, all the way up until 36. So it makes sense that our upper bound would be 36, right? Because that's the maximum value that we could roll. However, things get a little bit tricky when it comes to a minimum number. So we could either have 0, 0, or 0. So that's kind of tricky because if we do our range from 0 to 36, then it's kind of hard to tell if it's going to be 0, 0, or 0, right? And so what we're going to do instead is let's try to maybe set 0, 0 as -1. So if we make a range from -1 to 36, and we say 0, 0 is going to be -1, then we have basically one value for everything, and every number that we can roll, right? So let's do -1 to 36. Okay, and then we're going to create a new dictionary. So D is equal to, and then we're going to say number, colon, number. And then we're also going to add money and current bet. So money, colon, money, and then current bets, current bets. So this is basically just going to add our values to the dictionary. And then what we're going to do is we're going to add, we're going to append this to our list. So data.append D. And then finally, we're going to put this all into a data frame outside of our loop. So after we've appended this a million times, we're going to make our data frame. And then before I forget, we need to do our imports as always, because this is the first that we're running. So we're going to import pandas as PD. And then we're also going to import random since we're doing random.random. Okay, so let's give this a run. This looks like a pretty basic simulation. So again, all it's doing is, oops, Panda says no, oops, okay. DF is not defined. Here, let's try this one more time. All it's doing here is it's basically simulating us picking a random number from -1 to 36 a million times. Sorry, I got a little confused there, but basically I had done a little typo right here. It should be data frame. Okay, so once we run it, it looks like this, which looks good. And so now what we're gonna do is we're gonna run our test case to make sure that it looks good, which it does, perfect. All tests passed. Okay, so now we're gonna move on to part 1.2, which is adding each number's color to the simulation. And so the reason why we're doing this is because the whole goal of determining whether or not we win or lose is based on what color we land on, right? And so we want to be able to kind of figure out, depending on what number that we roll, like what color we're gonna get, right? And so what we're gonna do is we're gonna start by actually copy pasting our code from before, because we can reuse all of it, honestly. And what we're gonna do is we're gonna add a couple of if statements. So after we select the number, which happens right here, but before we add everything to the dictionary, we want to say if the number is in any of these numbers, then the color is red. Else the color is black, else the color is green. Oh, sorry, else if the number's in this list, the color is black, and then else the color is green. So I'm gonna actually copy paste this code over, and then I'll just do it right here. And then I'm gonna have to re-indent everything because Python is very, very particular about how you would do your indentations. So, oops, close this. There we go. So now that it's indented like it was up here, what we're gonna wanna do after this, so now that we've determined the colors, we're gonna add it to that dictionary. So we're gonna say color, color. Okay. All right, and so let's give this a run to make sure it looks good. Everything compiles, just good sign, and then let's view our data frame. So now we have our number and money columns like before, we have our current bet, and then look, our color's been updated. So that's good. Let's give this a quick run. All tests pass, that's awesome. And then now what we're gonna do is add result and next bet to our simulation. And so I'm gonna copy paste this code again, but what we're gonna do now is, depending on the color, we can now determine whether or not we've won or lost, right? So if the color's red, we've won. If the color's not red, we've lost. So we're gonna do this after, down here, after we figure out the color. So we're gonna say if color is exactly equals to red, then we've won. So what they want us to do is we want to represent our winnings. We're gonna set the value of result to be equal to our current bet. So result is equal to current bet. And then we're gonna say our next bet is gonna be back to 0. Sorry, back to 1. So result is gonna be equal to current bet, result, or next bet is equal to 1. Okay, and then else, if the color was not red, so any other color, so do else, we lost our bets, all right? So then what we're gonna do is we're gonna say result is equal to our current bet times -1 because we've lost that amount of money. And then our next bet is gonna be double the value of our current bet. So next bet is gonna be 2 times our current bet. And this will make sure that we can make up for all of our previous losses. So let's give this a run. Looks good. All right, so as you can see, what happened? Oh, we didn't add it. Okay, we need to add it to the dictionary first. So we're gonna say results, results, and then next bets, next bet. Let's give this a new run. Okay. As you can see now, we finally have our new columns. Okay, let's give the test cases a run also to make sure it passes, which it does, perfect. Okay, so now we're gonna move on to part 4 of our simulation, which is our very last step. And what we're gonna do is, again, copy over this code. And so, the last thing we have to do is, those variables we made in the beginning, we need to update those, right? So after we've recorded our simulation data, so after we create these, the dictionary, what we're gonna do is we're going to update the value for money and current bet, right? So money, as they say right here, is going to be results plus current value of money, like so. And then current bets is going to be updated to the value stored in next bet. So current bet is equal to next bet. Oops. Like this. So if we give this a run, and then view our data frame, we can run these test cases to make sure it passed, which it did. Perfect. All right, so now we're gonna run some code to show us a line plot so you can see, you know, across these 1 million games, like what does our money look like right now, right? Like, have we been winning? Let's see. Okay, cool. So it looks like we have been winning. As you can see, the y-axis is our current money, so that's in, guys, that's in millions, by the way. And then our x-axis is plays roulette, which is also in, millions, yes. So as you can see, like, it looks to me like after our 1 million game of roulette, we've won $500,000. That's pretty good. Or our current money's at $500,000. So that's a lot if you really want to sit through 1 million games of roulette. So that's really cool, right? And so the thing is, though, there's a couple of caveats, so let's look into those. A casino requires us to have a money to place bet, right? Like, we can't just not have money and go in and try to place some bets, right? And so if our money ever went below $0, we can't make a bet, right? So what they want us to do is, from our 1 million games, create a data frame of all the games with a negative starting balance. The DF negative balance is equal to, we look for, so we don't look for when our money is less than 0. DF money less than 0. Let's see when it is. So, oh my gosh, there is a lot. Oh my gosh. So there's a lot of times. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 times where our money goes negative. That's not good. Right? And so what they want us to do is they want us to find the required bankroll now. So bankroll is the amount of money you would have to have available to play at a casino, right? And so that's the absolute value of the greatest amount of debt you're in, right? And so that's the smallest value stored in money. So what they want us to find is, what is the smallest value stored in money, right? So we're going to do df money.min, and then we also, we want the bankroll required, so we're going to multiply by -1 to get the absolute values, because that's how much like positive money we need for that, right? So df money.min times -1, which actually, sorry, times -1. Oops. And so that is, you need $1.9 million. That's how much, that's the greatest amount of debt we were in at one point. So even though we like won $500,000, we were still like almost $2 million in debt. That is insane. And you have to remember that, like, at that point when we were in $2 million in debt, if we had to, like, if we had lost that game, then we would have needed to bet $4 million and then $8 million. So that is kind of like starting to realize why this betting strategy isn't the best, because if you don't have that money, then like you're not going to be able to bet, right, in Vegas at least. All right, so now we're going to move on to table limits. So this is also something that happens in casinos, right, where it's the maximum amount of money you can put on a bet on any spin of roulette, right? And so for our simulation, that limit's going to be at $10,000. So what I'm going to do is I'm going to copy paste my old code over, and we're going to add some table limits in. So we're going to say, so when setting the current bet, so that happens down here, right? We're going to say, check if the next bet is greater than 10,000. So if next bet is larger than 10,000, set current bet equal to 10,000 instead of next bet. Otherwise, set current bet as next bet as normal. So we're going to say, it's going to be right here. So if next bet is larger than $10,000, current bet is equal to $10,000. Else, otherwise, current bet is equal to next bet as normal. Okay, let's give this a run. Let's run our test cases to make sure it worked, which it does. All tests passed. That's great. And so now let's create a new visualization. Let's see what happens when table limits are put in place. Oh, okay. So looks like we're going into major debt, almost $400,000 in debt. So the second that we place those table limits, things are not looking quite good for us. But the last thing is we want to find the total money lost. So after these 1 million games with table limits, let's find our total loss. So that is going to be that's going to be negative money, right, plus $100,000, because money is how much money we have, so negative money is how much money we've lost, right, because we want it positive. And on top of that, we've also lost that initial $100,000. So let's give this a run. Oh my gosh, so that is, we've lost almost $500,000. So that is not great, right? So our initial $100,000 turned into like $400,000 of debt. And so main takeaway here, right, is that this betting strategy, when we introduced this, like when someone told this to me, like it didn't seem like a crazy idea, right? And even when we like visualized it at first, we saw that like increasing line, right? But the second that we become realistic and the second we introduce those table limits, then we're able to the casinos are able to prevent us from doing this by prevent us from making up for those massive streaks of bad luck, right? And so that's initially our downfall. So let's submit real quick. So I'm gonna go here, and then I'm gonna commit my work with these 3 commands in my terminal. Okay, and then I'm gonna go over to my MicroProject, and then I'm gonna run a workflow. And I'll be back in a second when I'm done. All right, it looks like our MicroProject is done grading, so let's give it a look. It looks like we passed all tests, which is great. If you ever have any sections where you don't pass all the tests, for example, earlier today, I messed up one of the values, I think, for next bet. Be sure to go back to that section, especially because that one section can also affect all the ones below it. So with that being said, thank you guys so much for watching. I hope you guys had fun coding together. And yeah, see you guys in the next one. Bye.